I kind of would give people permission to have fun, right? To be curious, to enjoy the work they're doing, to dig in a little bit, to just have fun in this industry. It's not easy. I'm not saying that at all, but I really do think there's something about the software industry, the tech industry that's inherently fun. And you know, I kind of want to just tell everyone it's okay, have fun with it.
Hey everyone, welcome to Dev Interrupted. I'm your host, Dan Lyons, and today we're joined by Randy Kern, CTO of Marqeta. Randy, welcome to the show.
Dan, thank you so much for having me today. Looking forward to it.
Yeah, awesome to have you on today. A little background, some notes that I have about you. You're a tech veteran, so you have decades of engineering plus leadership experience, which is fantastic. In particular, you've spent much of your career, I think, on the enterprise side. So previously, you served as Chief Customer Technology Officer at Salesforce. And before that, you were at Microsoft, where you worked on Azure and Bing technologies. And chatting with you, a bit before the show started, it's obvious that you have a real love for the craft of coding. You said something like engineers should go deep all the way to understanding how the transistors work, because that's not only how you build better systems, it's how you have fun. That's like a pretty cool quote. But before we dive into all of that, our talk's going to be a lot around mastering the craft and becoming an expert. But before we go there, would be great to know a little bit about you and your career and your background and how you got into tech and what you're all about.
Oh, that's great, Dan. I think we'll have fun. So I really do care about the craft of programming. And, you asked how I got here. I think that's frankly a lot of it. As a kid, I got interested in technology and computers. One of the first things I started playing with was my dad's calculator, paper tape calculator. And that was a blast. And I made ham radios, so I burned my fingertips with soldering irons and figure out how transistors and capacitors and everything work. And built amateur radio stuff. I'd listened to long range radio. I had a ham radio license, and I don't know, it was just technology of all types was fun. Yeah, even things like taking apart a washing machine and putting it back together when I was little was enjoyable. I just always wanted to know how stuff worked. And I don't know, so somewhere from the kind of hardware has the real world work, I started to find this world of software, whether it was, writing this silly lunar landing game on my dad's calculator I was telling you about. I got a TI 994A, an old computer, and actually even before that, an Altair 8080, that old like toggle switch thing. And so the thing I loved about that whole space was the software part. Right? You could change it. You could teach it to do anything. It was a whole world to figure out that, I know, it was more malleable than hardware. So that got me into this space, and it was just fun to figure out. I just had a blast.
That's awesome. And it feels like that era that you're talking about, or the way that you describe it while you were talking, it feels so pure, like no intentions around like money or like, I don't know, I got to build a social network so like 1 billion people can like, I don't know, chat on there, look up to me. It just felt more childlike and pure. And that's what I love about the spirit in which you talk about it. And what about for your professional career? Like, how did you evolve in that? Where'd you get started, and a little info there?
Yeah, I've in all honesty had kind of a strange route here, and it's all been driven by that kind of childlike curiosity you're talking about, right? It's about what can I learn, and where can I go do something fun and be surrounded by smart people and kind of expand my knowledge, and just figure out how to make these super cool computers do something even more interesting and even more, at least personally, rewarding than I did before. So I got into programming, as I said, really just for fun, right? And it was neat stuff to learn, and Boolean algebra, like I thought was way more entertaining than, the rest of mathematics that I was studying as a little kid. From this, the first kind of like real software I wrote was an accounts receivable package. And it was the the newspaper, the small community newspaper in the town I grew up in. I grew up I'm in Seattle right now. I live down in San Francisco, but I'm in Seattle right now. And the town I grew up in was called Camino Island. It was a very small neighborhood or a very small area. And there's a little town next door called Stanwood. And they had a community newspaper. And I don't even remember how this happened, but my dad was talking to them and they were having problems with accounts receivable. And this was all done, I think at that point, with typewriters and putting bills in mail and depositing checks.
Old school. Yeah.
Totally old school, right? 100% old school. And I'm like, oh, wait, I was talking to my dad, like, we can make that better. We can do this better. And so I built an accounts receivable package in DBase on a PC with MS-DOS. And we sold it to the newspaper. And we sold that same account,
Cool.
AR package to another local store. And, just sort of did this random stuff and would learn about the business need. And we'd talk to people and then I'd figure out how to make some software do it. So that was a hoot and just I don't know, it was in retrospect, it was a really weird experience, but being there in the moment seemed totally normal and natural that I'd be, figuring this stuff out and reading books on accounting and writing software. So that was fun.
Cool.
And
that's really
that
cool.
was really my, that was my first avenue to it being kind of a professional thing, if you will. I should add as an aside, I didn't think I was going to go into software as like a career. I thought I was going to be a musician. I played the viola. I loved classical music. I thought symphony music, chamber music, like that was going to be my life. And now here I am, 30 years later, still in software, and I don't dare pick up a viola. It sounds terrible to me anymore.
Yeah, that's great. It seems like it all came, pretty natural to you. I love that story that you did with your dad and on the accounting stuff. Again, it feels like that is like almost like the golden age because you had all of these, business. I called it old school when I was just talking about it, but it was like, sounds like it was that era where it's like, okay, anything that we're doing manually by hand, we could bring in to software on the computer. And yeah, that's kind of where it all started. You were a mini entrepreneur, a nice entrepreneur there. Now, one of the things that I think you're passionate about, kind of our first topic here, is around mastery or beginning the path to mastery. Your advice to new team members is to start by spending a month fixing bugs. What's the essence behind that? Or maybe it's just straightforward, go and do that. What does that mean to you?
So I got to that advice by following that habit myself. And this was really from the time I was at Microsoft. And, if I would join a new team or start working on a different part of the product, maybe I was already part of, I realized that the quickest way for me to add value and even more interestingly, or more importantly for me personally, the quickest way for me to figure out how things really worked and not have just a cursory understanding was to pick up a debugger and kind of see how it really worked and fix a bug. And so I kind of got in this habit myself of just, opening the bug database at Microsoft in the 90s. It was called RAID, RAID, just like the bug killer. So that
I remember that.
That was in use.
The bug killer.
Exactly.
Is that still, maybe that's not even allowed anymore, RAID? I think it might be.
I have no idea.
I think they got rid of it or something. But yeah.
I know Microsoft's bug database isn't RAID anymore. They've gotten a lot more advanced over the years, but that early one was simple. But it got the job done. And, as a developer, as an engineer, like it was perfect, right? Because you'd pick a random bug, you'd read the repo steps, you'd figure out how to run the product, how to reproduce the problem. You're like, oh yeah, okay, it does what this person said it would do. It does what this bug report says. And then it's this perfect sort of guided tour of what's actually happening in the software. Not sort of just the mental model of how you think it should be, but you're literally kind of walked through step by step of how all of this gets to be. And it may not be immediately obvious how to go about fixing it. And sometimes that's kind of subtle, but that's okay, because that's going to spark good conversations with folks and engineers who've been in that team longer and understand it better. And so you can say, well, I understand this part of it. And I got to this piece of code, I saw this, but it seems like maybe there's something over here that I don't understand. So I don't know. I always just found as it was a way to get real very, very quickly. It was a way to sort of
Yeah.
focus instead of looking at this huge code base and be a little daunted and you're like, I don't even know where to start. And, how do I start to build my mental model of how this works? Kind of following an actual bug report and, literally stepping through the code line by line to figure out how you get there and kind of where it all goes
Yeah.
awry. It was perfect. And so I love that. And so I've started just to encourage folks whenever they change teams or when they join me somewhere to do the same thing. It's a great bootstrap.
Yeah, that's really, really cool. I actually, while you were talking, I was thinking of my own career, and definitely when I would fix bugs or fix a lot of them or dive into it, there was these unknown parts of the system that were like black holes to me that then became light to me. Like, oh, okay, like I haven't been here before now. Because the first thing usually that you need to do is fix a bug is like try to understand the flow of what's happening. Like, where does this bug occur? So you got to get a good mental model there. And for, the leaders listening, what came to mind for me is maybe this is a good onboarding path. Maybe you're at a bigger company or you need to how do we bring on a new engineer? Maybe you need to fix 15 bugs before you even do anything with a feature. And the last thing that came to mind, your teammates will definitely like you if you're contributing and fixing bugs. Say, hey, that this person, they're really trying to help. It's a good way to get in, I think, socially as well. You see that with open source projects or anything. Someone that's willing to go in and not just say like, oh yeah, I built the next new shiny thing. It's like, no, I had to research and fix this bug. I think that goes a long way.
Dan, listening to your
Now,
point there, this all
yeah, go
kind of
ahead.
ties back to mastery. The recognition that making what we already have better and really understanding it as opposed to being sort of maybe overly drawn to or fixated on the new stuff, the periphery, whatever is on the edges. Listening to you reflect on that a bit, what I hear brings it back to this desire in me to always strive for mastery and always help my team strive for mastery. I think that not only does it lead to better outcomes, but frankly, as you said to start, right, it's more fun.
At a little bit later point in my career, I actually was thinking, okay, so a bug would happen, in the system that I was working with, or like I was a team leader or whatever it was. And I would hear what the bug was from a developer, like a teammate. Hey, this isn't working. And I would think to myself, without even diving into the code, what's my instinct of what got broken here? And it's funny because I would and I wouldn't even be the one always diving into the bug. Someone else might go in and fix it or whatever, and I find out what it was. I could kind of actually measure my mastery of the system by if I had good instincts, just thinking about, I bet it's this or I bet it's that. And the more time that I knew that, oh, yeah, okay, it is what I thought, I really know this system. And then times where it was like I was way off. And this is like when I was a manager too, I was thinking, wait, maybe I'm getting too disconnected from the code. Like I don't have a good instinct of this anymore. So kind of use the bugs in that way to measure my mastery. I don't know if you've ever thought of it that way.
I haven't, but I like that a lot. And I often think as you understand a product, as you understand a code base better and better, your mental model as to how it works is more complete, and to your point, is more accurate. And this
Yeah.
idea about sort of being able to pre-debug a problem just by thinking about what most likely led to it. It's a great sort of early indicator metric of the accuracy of your
Yeah.
mental model.
Yeah, exactly. And of course, if you're a great hands-on team leader, you can give people tips. Hey, I haven't dove in yet, but you might want to look here. That's like this type of stuff that I would start doing. So, yeah, I mean, a lot of good stuff there around bugs. Now, one thing that I don't know what your feeling is on this, but is there a trend that developers are moving away from mastery? You have a lot of like the Stack Overflow stuff. You can get code, wherever you want, snippets, that kind of thing. A lot of companies are very like feature driven, like I was talking before, like, hey, got to get the next feature out. What are you seeing in terms of trends with engineering, new engineers, engineering teams now in terms of mastery?
It's a great topic. One of the things that I think about, when I was getting into this, there was an idea of how software could help businesses and do interesting, fun things for individuals. And there was certainly a vision that there was a big business there, but I don't know, it felt a little less commercial, least in most engineering teams and most development teams, it felt less commercial. And so I think it somewhat naturally gave people a little more time or at least a little more space, not necessarily time, because we always worked on crazy deadlines, but it gave people a little more mental space, I think, to hunt for elegance, to kind of think about some of these things. I have a very simplified model of sort of the career stages of a developer, right? And early on, your all of your energy, all of your capacity effectively gets consumed just making the thing work, right? You've
Yeah,
got a task at
I
hand,
agree.
whether it's
Yeah.
fixing a bug, building a new feature, whatever that thing was, right? Whatever you were asked to do. And it sort of takes all that you can give just to make that happen. And yeah, the solution may not be that great. It may not be very elegant. It may not be very easily understood by others. It may not be maintainable. It may not scale the feature. Who knows, right? But you did solve it. You got the problem solved. You pulled that off. And for the first, let's randomly say 2, 3 years of your career, that's probably all you should worry about, right? Just keep doing that. It'll get a little easier, a little easier. But then folks usually come to a next phase of their career where they sort of understand the mechanics and the work we're talking about well enough that it doesn't fully consume you any longer. And you have a little more to give and you have a little more room to even be curious and to start thinking about second order things, right? And you start thinking about, how do I actually do this better, right? It's not just how do I do it, but how do I do it better in whatever dimensions and ways that might mean. And yeah, in that second phase of a engineer's career, it's usually you struggle through it, you get it working, and then you're like, wow, I really don't like that. And I now see all these ways it could be better. And you try to get room, you try to get space, you try to get time to rebuild what you just did in this better way. Like take the
Yeah.
lessons you just learned
Yeah.
in making it work and throw it all away, start over and rebuild it following those lessons learned. I think to kind of fast forward to your point, it might have been a little easier to have time to do that rewrite, 20, 30 years ago when we were building packaged software than today when
Yeah.
everything almost is hyper incremental. And, even if it's running on a laptop or a cell phone, it's probably some iterative release. It's a push update, it's not a 3-year cycle. And so that getting through that is a little tricky. And then just to finish my thought, the phase after that kind of is when, before you're even starting to struggle through how to build it in the first place, you can see into the future a little more easily. You have that mental model of how it's all going to fit together in the end. And now you're a little more able to actually build it the way you want it. It's never going to be perfect. You're always going to learn along the way. In fact, that's one of the things I think is fun about this industry. You learn as you go. Each and every day,
Yeah.
you're smarter than you were yesterday, but you're a little bit more able to actually map out how you think it should be and be a little closer to the pin, if you will, when you start. So, but to your point about, is this as true as it once was? I think the kind of software we build, certainly the complexity and the levels of abstraction that we have are very, very different than it was 30 years ago. And I
Right.
think it makes it harder. You can still do it. And I still think it's much, much, much more rewarding for someone's career to invest that time, to invest that energy. And you certainly get to a different range of value that you can bring to a product or to a team or to a company if you kind of push yourself through those phases. But it's hard to do. It's really hard to do.
Yeah. Actually, like two things came to mind. A phase maybe after like the next one to add on to what you're saying. I felt like I kind of really leveled up my career. I went more on a management track, so not on like a staff engineer track. But when I started to say to myself, okay, I have a solution. I think it's a great solution, high efficiency, high quality, right? And then I start knowing really how the system works. Then I started thinking, how does this impact, like my solution impact the people like reviewing my code? So I'm putting up a big pull request or a small pull request. What's the release going to look like for this? How are we going to load test it? What's it going to feel like for the next person to come in and have to edit? Once I started thinking that way, so that's kind of like this, not only the system, but how does like our engineering release process look like? That's where I felt like I got, at least for me, my next jump, and I could start seeing how my code actually impacted everybody. So I don't know if you see that as well, but I saw that as like a next step in my career.
No, I think it's a great point, right? And it's you highlighted readability. I would add testability and the just
Mhm.
a- the impact, especially now, is a lot of what we do. Our services are kind of very very dynamic systems. The impact in the whole system around just the piece of code and what's happening in those transistors has just gotten bigger and bigger over time. The impact on your team, there's the impact on kind of future choices that are easy versus hard. That it has, one of the things that's fun about this space or this industry is you can go incredibly deep on many, many, many different problems in many, many different areas and really sort of lean in heavy to the research and to the science underneath it. And you can also go really, really broad in sort of how this system of technology and people and business and customers, like all of these different areas collide and interact in really nuanced, interesting ways. And this is an industry that has both of those in spades. And so
Yeah.
I don't know, from my standpoint, there's always more to learn and there's always more to play with and experiment and try.
And totally agree. And what I felt like, I felt like I had to carve out my own space or my own time to go in depth. That's the truth, actually. Because for me, I was working in startups like my whole career, always a deadline, always had to get something done by Friday. I really had to carve out my own time. And when I started to really understand like our infrastructure, where was my code really running? What was the impact of it? You know what it really did for me is boost my confidence to join a technical conversation, my confidence to have an opinion usually in a meeting or like either technical or business. There's like a confidence skyrocketed with that. Like, I really know what I'm doing here. Let me try to like contribute back to the business. That's what it did for me. So I highly encourage everyone to dive in and carve out some of that time. What I wanted to ask you, Randy, is kind of have a question here. Like, at a minimum, what do you think all engineers should understand that maybe they don't, but where is it that you should dive in, or if you get that extra time, what do you think every engineer should know?
For me, it's truly understanding how your code is working. Not just that it does, not just that it does work, but what is actually happening. And when you and I were talking before getting ready for this, I was talking about all the way down to the transistor. That's a lot harder in 2022 than it was 30 years ago.
Yeah.
So that may be asking too much. But understanding what the operating system is doing on your behalf. If you're writing in a managed language with a managed heap, understanding what's happening there, understanding what any framework or library is doing. That not just kind of at the highest level of what the code you wrote is doing, but having a at least a rough idea of what's happening under the covers for all of that to actually occur. I'll give you a couple examples, right? It's really common for people to write a JSON API over HTTP. Do you really understand how the HTTP protocol works? And that's still really high in the stack, right? Do you understand that? And
Yeah.
the most current HTTP is relatively complex. You know what? Okay, go back to 1.0, understand that. The concepts have evolved. A lot of the weaknesses have improved and gone away, but start there because the basic idea is still very, very beneficial and it's easier to understand. HTTP runs on top of TCP. Do you understand how that works? Do you understand the weird oddities and, not every last single detail, but, do you understand how a connection is made? Do you know what a synac is? Do you just like give yourself the time and space to go through that? Do you understand how the Ethernet card in your computer talks to the switch and, how they learn to route packets? How does ARP work? I pick it on networking. Not everyone needs to go deep on networking, but as a concept and,
Yeah.
do the IO, how the CPU and the operating system manage the IO interrupts to actually send and receive that from the Ethernet card and get it to the right socket in your program. And, it then eventually turns into this JSON API or this JSON response. And you're not going to understand every little last bit of that, but don't be satisfied with just huge black boxes that you don't understand at all. It doesn't mean that you can go write a TCP driver. That's fine. Doesn't mean you can go, fix a bug in a relational database or invent a better database. That's fine. But when you're using these things, they're very powerful, and abstraction, I think, is really, really, really important. But it's also really risky if you don't understand what it is actually doing under the covers.
Right.
I'll give you an example that my team came across just a couple months ago in Marqeta, the company I'm at now. They were working on a relatively conceptually simple service. Takes an API request, makes a couple other API requests, and it basically aggregates the results and sends back a response with a little bit of logic. So it's conceptually pretty straightforward. It doesn't do a lot of processing. It's mostly IO. And they were talking to me about they were bringing on a new customer, was going to add a bunch of load to this service. And they were talking about adding, I don't remember the exact number. Let's randomly say 10 or 20 more servers worth of capacity to do this. I'm like, wow. So, how much capacity are we running already? Basically, what's the QPS? What's the request per second for this new customer? Because that's a lot of hardware.
Yeah.
And I don't remember the exact number, but it was like a few hundred or something. I'm like, wow, we like just based on I must not understand something here, because my mental model, like, we shouldn't need 10 machines to, run a few hundred transactions per second or requests per second for the kind of processing I'm expecting here. Anyway, long story short, the team went and looked at it, did some diagnostics, looked at things a little, much more carefully, and realized that we were doing synchronous IO for all of those calls. And so,
Yeah, there you go.
the machine wasn't anywhere near capacity bound, but we were out of threads, and we were, it kind of hit congestion collapse instead. And yeah, it was a relatively quick change to move to async IO. And, next thing you know, obviously much, much, much higher capacity in that service. Now, was it super important to do that? Maybe, maybe not. But it certainly makes it easier for us to manage and run that. It makes it more cost effective. And
Yeah.
that now is sort of a level of understanding that whole team has to take to everything else they do in the future. And frankly, it makes your software much more robust when you don't have, when you're not close to the edge. So it's just an example of peeling things back a little bit further to make sure you know what's happening under the covers, underneath your very powerful and very useful, highly abstracted Java stack.
I think it's like a really good example. In your example, probably everyone on the team kind of leveled up their knowledge for the future. Oh, okay. Now we get it. We're not going to do that again. You know, you mentioned costs, for example, but yeah, speed, efficiency, just a
Mhm.
better way to do it. So I can probably guess that you think of, engineering or development as an art form in some sense. There's kind of like the science behind it, the art behind it. That's usually why it attracts, a certain type of people. And it seems like for you, Randy, you probably, 'cause what you told me about your childhood and all of that, you probably spend a lot of your spare time kind of digging in under the covers. You want to figure out how it works. That's kind of just in your nature. And that's great. But if we think about it from like a team leader perspective or a manager perspective, or you're the VP of engineering, you had talked previously about deadlines and sprints and iterations and all of that. What are your thoughts around enabling this exploration that doesn't necessarily have to do with like hitting a feature deadline on Friday? if you're a manager, like what are your thoughts on enabling your team?
I try to balance the here and now and the future. And it's very, very hard to do. But what I mean by that is I sort of think that building software, running services, supporting teams, it almost takes bifocals, right? You need to be hyper focused on what's happening right now, on the quarter, if you're a public company, on, the next week, maybe if you're a startup. So you're really, really focused on excellent execution right now, the signals and feedback and what you're learning from happening, so you don't get disconnected from reality. But I think you also need to be thinking about how are we better in the future? And I don't mean, having written like the perfect roadmap of, 3 years of development and the perfect technical LRP. I think those are useful exercises because they help guide our thoughts, and they help, to your point, carve out some time or force us to dedicate some time to that work. But even in a smaller way, always trying to be thinking about how is the future, how is the world, how is our team, how is our software better, next week than it was last week, next year than it was last year. And so in order to do that, if you can believe that you can make the product and the team a better fit for the problem at hand, i.e. something that you'll be able to move more quickly, you'll be able to create more value given the same resources, same time. If you fundamentally think that you can get all of this to a better point, that we can improve our skills and our understanding, that we can improve the architecture and structure and abstractions in our software so that we can move more quickly and add more value, then I think it's really important to find some balance between just, adding the next short-term bit of value, this sort of underlying multiplier value of let's be in a better spot than we are today. And so it's hard to do, but I think you have to always be thinking about it and always balance it, right? And it's a little
Yeah.
like tech debt, right? The goal is not to have zero tech debt. Like the only companies I've ever met with zero tech debt also have no business. So
Yeah.
you're definitely going to have those kind of challenges, and that's fine. The trick with tech debt, though, is, if you let it get out of hand, if you let it get too high, then you kind of get to the point where all you can do is pay that interest. All you can do is pay that debt. And so it's about finding a way, and this is a very, very hard thing to do as a leader, but finding a way to have that balance in all these different domains and different areas. And, part of that, I think, has to be making sure that the team and the software and the service and your customers, that whole ecosystem, Dan, you and I were talking about earlier, it's got to be in a better spot in the future. Not just, better features, richer capabilities, more customers, but a sort of a better fit to the business. So you can change it, you can evolve it, you can measure it, you can prove it more effectively as well.
Do you have any tips on if you're a manager, like VP of engineering or whatever, of how to balance it or how to ensure that balance happens?
It's very hard. I'll start with
It
that.
is.
The,
It
the, the
is.
second thing I'll say is getting visibility and data into where people's time is really going is really, really, really helpful. And it helps you be honest as a leader. It helps you sort of at least provide some guidance and guidelines to the team. And I think it helps give engineers, the rest of the team, some of the support they need to do what in a lot of cases folks know is kind of the right thing already. So, maybe you can classify JIRA tickets as different forms of work and different places that you spend your time. Maybe you even spend a little time and shadow some people and just take a whole bunch of notes in a notebook and get a sense of, where their time is actually going and what reality looks like. There's various ways, but I think starting with some data, and it's going to be imperfect, right? This is not a high precision exercise. The idea is not to figure out,
Yeah.
is it 39% or 50 or 41%. The idea is to figure out, are we spending some amount of time in making the future better for ourselves? Are we spending some amount of time in addressing scalability, in reducing, work that's kind of toilsome. So you're spending some time, you talked about deployment systems and kind of where your code goes. Are we making that smoother so engineers get better feedback? Whatever those are, I think any visibility you can get into the reality of where the calories and energy on your team are going will help you make better decisions. And let's be blunt about it. Even once it can be very, very hard to make those trade-offs and make those decisions. You're worried, especially if you're in a startup environment, you're worried about that very next sale. You're worried about that next bit of revenue. So finding the right balance between just hanging on in the short term and investing in your future, it's not going to be easy. But the more you
Yeah.
talk about it, and I think the more data you have, the better you can do. And experiment. Doesn't mean you have to. If you want to say, we're going to put 20%, 30% of our energy into making our engineering system better. You don't have to do that across the board, right? You could experiment and try that in one scrum team and see what happens.
A lot of things come to mind. I'll try to rattle them off here. So one thing is data is a great justifier. So especially if you're like an engineering leader or VP of engineering, actually one of the reasons that I founded Linear B. Linear B is providing metrics, around engineering productivity, looking at that pipeline. One of the things that it allows an engineering leader to do is go back to the business, usually like a CEO, a non-technical person, and be able to show visually, hey, we're having a lot of problems with deployments. Let me show you how it's slowed down over time, for example. So data is kind of a big like justifier or equalizer. And that's what came to mind to me. One thing that when you were speaking, make sure, especially if you're going to business folks, that you come with data. Because if you just come and talk about like technical concepts, it's not their fault, but they're not going to like, it's almost like they're not going to hear you. But if you say, look, the amount of time it takes us to deploy value to customers has increased by 50% over the last 2 quarters, bam, they're going to listen. And I can show you on the graph. The other thing that I would say that I've seen in my career, one from a VP of engineering and one from an engineering, I call team leader, like a line manager, like leading a team of 8. With the VP of engineering, what you do have the ability to control is kind of like your cadence of work. And I'll describe what that means. You can also go back to the business. Again, these are like your executive peers and say, listen, like I'll give Linear be another example. We're a high growth startup. We do not need any more pressure around feature delivery, customer deadlines. We have huge customers coming on every day now. That is naturally there in a high growth startup. But what we did need, and this is what our VP of engineering, REL, did, is say, hey, after every sprint, we need 3 days of quality days. That's where all of engineering has the time to work on technical debt, rewriting something more efficiently, fixing bugs, studying some piece of knowledge. And that's actually baked into our cadence and like signed off by the business, right? So it's kind of baked in. That's one way I've seen it done. And the other thing that I would just share is if you're an engineering manager, what I've seen, you don't have as much, let's say, power to say, how does the entire engineering, org operate? Well, I had seen some leaders that remind me of you, actually, Randy, is they will say with their team, hey, every Friday at the beginning of the week, Monday, we're going to pick one person. So let's say I'm the manager. Hey, Randy, on Friday, we're going to give you some time to do it this week. Could you give a presentation back to the team of how does HTTP actually work in this particular call, and trace it for us or whatever, I'll give you time during this week. You're going to present on Friday for 15, 20 minutes and you rotate it. So you kind of build in that culture that it's cool to dive in and then show what you learn. I saw that work as well. So just wanted to call out like a few tips there that I've seen. Our last area before we wrap it up, have a note here that you've led teams of 25 to 4,000 people. Is that true? That seems like a
All
very
right. Yeah.
high number. Okay. So,
All right.
kind of like smaller teams to huge teams, right? That's an enormous size. For aspire, we have like a lot of like aspiring leaders that are listening to this pod that would say, "Wow, I would love to be, in that situation, just like you, Randy." Is there anything in particular for people that are interested in those more enterprise? You were at Microsoft, like enterprise companies leading large groups of people. Any advice or takeaways that you would want to talk to someone aspiring to do that?
The spot I would start is really invest in recruiting and growing your leadership. Because the only way to scale, realistically, the only way to scale really past 50 or so is through others. And, so that means recruiting and attracting folks who have done it and are really good at it and are learning and growing. And of course, to help people grow and learn and help your sort of whole environment and whole management team learn and grow. There are inflection points of scale, up to 50 or so. And frankly, even sometimes 100, you can kind of do it by yourself. I don't advise it. It's not the best way, but you can kind of do it by yourself. That break point to somewhere in the 250 to 400 range, you can sort of do it with yourself and a few other people who do it by themselves, right? So you can do sort of just directly with your leadership to a team with your directs. Through that point, wherever that break point around 250, 400 is up to many thousands, it's a different game because you really need that middle layer to be those same kind of leaders, that same kind of show up in that same kind of way and bring excellence to the team, support the team, attract, recruit, grow folks. So, at the end of the day, the fundamental thing that has helped me scale, and I have seen that help many other leaders scale over the year, is you have to bring in really, really great people and you have to grow really, really great people. I don't think there's any other way to do it, to be honest. And it's interesting. Sometimes I'll see reluctance. I'll have really great leaders, really great team managers, and they're folks in that. Let's put them in that 20 to 50-ish range, and they're doing a really, really good job of that. But they're not quite getting the folks working for them who could also take over a team of 50 or even a team of 150. And they're fiercely loyal and supportive of their team and of their folks, which is wonderful. But they're not quite able to distance themselves yet from that and see how important it is for them to have the bench that, maybe they don't need right now today, but they certainly need in order to do, that next break point of scale. So, over and over again, it is bring in folks who are stronger, more experienced, more scaled, really, is what we're talking about here, more scaled
Yeah.
than you think you need.
We could probably do a full podcast just on this topic alone. But what I would say is I think you're completely correct. And usually what I tell managers who are trying to scale a team, and sometimes they don't believe me, is it is actually all about recruiting, or like 80% while you're scaling. And I say to them, like, what is the first thing that you do when you get into the office in the morning if you're scaling? I think it should be working on recruiting and making sure that you have the best people, the top talent that can help you scale. It sounds crazy, especially in a technical position, because you might say, oh, I want to look at something in the infrastructure or tech debt or efficiency or how we work. But it's actually, you wake up and you work with your recruiters or see, like, do I have the best process there? And that's how I've seen people get to these scales of hundreds, 500,000 and so on. So, as I said, we could probably do a full pod on that, but it's good to hear it from you that you're kind of in the same mindset. Wrapping up here, we talked about a lot of different things, but if there was one takeaway or one thing that you would like the audience to kind of hear in this pod, what would it be?
I kind of would give people permission to have fun, right? To be curious, to enjoy the work they're doing, to dig in a little bit, to just have fun in this industry. I mean, it can be high stress. Depending on the business you're in and the situation you're in, it's not easy. I'm not saying that at all, but I really do think there's something about the software industry, the tech industry that's inherently fun. And I kind of want to just tell everyone it's okay. Have fun with it. You have my
Okay,
support.
perfect. Yeah, that's unbelievable. And I think that really was the spirit of this pod. And so, Randy, thanks so much for coming on Dev Interrupted today. It's been a really, in your words, like a fun conversation.
I had a great time, Dan. I appreciate it.
So before we go, I know you may have some hiring opportunities. Can you give like a quick word? What do you got going on for availability for careers?
No, thanks for the opportunity, Dan. So for those who are listening, if you liked what you heard, if you think this would be a fun place to work, if you're interested in learning about fintech and really kind of investing in your engineering or product skills, look us up. Take a peek at the Marqeta careers page, and I'm always looking for great folks to join us. And frankly, come have fun.
Amazing. Thanks everyone for joining us today. If you enjoyed this episode, please reach out to us, leave a review. We read every comment and we really appreciate your feedback. See you all next week. And one more time, Randy, thanks for coming on the pod.
Thanks so much, Dan. I had a great time.